Alright, here we go with number 27 on page 141. So the question was, or the beginning part said, consider the equation x cubed plus y cubed minus xy squared equals 5. In part A, you will asked to find the derivative. So the derivative is what we have right here, which when you solve for dy dx, you will get this. So the question wasn't about this one, but that is happens to be the answer. So if you need further explanation on that, you're going to have to ask me. Okay, so then we had, if I can move this guy up, I forget how to do that. I don't know how to do that. Maybe just turn this off. Oh, here we go. All right. So B and C were just to after you found the derivative, just to put in table values, etc. But part D was find all the points where the tangent line is horizontal or vertical. So if we want to find out where the tangent lines are horizontal, we set the numerator equal to 0. When we want to find out if they're horizontal, we set the denominator equal to 0, because that will give us a undefined derivative. So we are just going to find the horizontal tangents, and really it's the same process to find the vertical tangents. So we set it equal to 0 and we solve. So when we do that, hopefully this will work. It's probably going to be a little bit sloppy here, but you're just going to add 3x squared to both sides, and then we're going to take the square root of both sides, not forgetting to do plus and minus, because we're going to get two roots. So we're going to do plus and minus, take the square root. Oh, actually that's not plus and minus, but that's just going to be the square root of y squared. So we get plus and minus the square root of 3x squared. Well, that's a product, and one of those products is a perfect square, so it should all work out to, when we're done with it, should all work out to this. So if we substitute this, because really that's, these guys are both the same, back into the original equation, we are going to get x to be approximately, well, if you plug them back in, okay, if you plug back in, or if you plug in this guy as,
behind the scenes and other special features from our movie of the week.
Don't mind that, it's just my TV. I was watching Dexter. Anyway, if you input that in for your y's here and here and solve, you will get the value for x. So I'm not going to do all the algebra, but you're going to get x cubed plus, and you can do plus and minus. I mean, they're virtually going to be solved the same. Cubed minus x, minus x plus or minus the x cube root of square root of 3 equals 5. So if you solve all that, again, you're going to get y, you're going to find x first, which are going to be these two values, and then you're going to substitute those two values in to find y, and you're going to get those two values for y, and again, getting those 2 points. So it gets a little bit heavy algebraically, but that is what it comes down to, and it's exactly the same way, same process to find the vertical tangents. Hope this was helpful and coherent.